Alright, hello and welcome to today's lesson. This is Mr. Ludden, and today we're going to be having a look at ending a maths exam question. And more specifically, we're just going to be looking at when you get your answer in the exam, making sure that you get your full marks. So you might have all your work out done and you might have your answer at the end, and you might have the 9 out of your 10 marks for that question in the bag, but the last mark will be how you present your answer at the end. So we're just going to focus on that today. This is a follow-on lesson from my video on starting the maths exam question, and I'll put a link to that in the description if you want to have a look at that as well. So I'm just going to pop back to the question that we did in my previous video, or the question we had a look at, and it was from 2019 paper 1. It was question 10. So we have our actual question here again, and this is our marking scheme. And in the last video, we just sort of focused in on the word at the start, the command, I suppose. So the word draw. And you knew that in order to get your marks, you had to draw something here on your on the graph they've given you. And that was all well and good. But for this video, we're going to have a look at the ending here, and more specifically this bit, the bit that I've just put a sort of rectangle, I suppose, around. And if you weren't familiar with exam questions, sometimes that might throw you off because there's a lot of symbols there. There's some things that maybe you hadn't seen before if you hadn't been looking at exam questions, like that E. And sometimes students can be put off by this. If anything, this bit here, it helps you out more than you realize, I suppose, in the question. So if we take the question as a whole, they're asking you to draw a graph here, and you end up with something like this here as your answer at the end. Now, you'll notice that you've only drawn a small bit of the graph there. You've only gone like that little bit there. If you were to type this into Wolfram Alpha, which is a computer piece of software that'll graph out any graph that you want, and I'll put a link for that in the description as well. But if you were to put this function into Wolfram Alpha, it would go on forever in both directions if you minimized the actual graph. So in this one here, we're only looking at this little segment of the graph, but of course the graph could go on like to 3, to 4, 5, and back to -3, -4, -5, back to minus infinity, and up to plus infinity as well. So you'll notice that the graph that they've given you, it only goes from -2 to 2 on the x-axis, and really that's exactly what the same thing that they're saying in the word part of your question up here. So what they're saying is, well, x, all your x values, they have to be greater than or equal to -2 or less than or equal to 2. In other words, your x has to be in between -2 and 2. So it means basically the same thing as what they're showing you on the graph there. Now there's one last bit. They tell you a piece of information about x, and they say that, well, x has to be an element of your real numbers. That means that when you are graphing this, you should take into account all the real numbers between -2 and 2. So if you think back, and we will be getting onto this in a minute or two, your real numbers are your positive and negative, whole numbers, and also any decimals that you can think of as well. So just as an aside, for leaving cert, you look at the opposite of real numbers, and they're called complex numbers, but we won't talk about those right now. For now, for your real numbers, they're any numbers that you've come across up until your junior cert. So positive, negative, decimals, fractions, whatever numbers you can think of at the moment. So what that means is, seeing as x is an element of your real numbers, that means there should be no breaks in your line, or not in your line, but in your graph. So you'll notice that in the answer here, you'll notice that there's no breaks in the actual curve that you get. Now, if you were to actually do this question, you wouldn't get every single point on this graph. You would sub in your x values, the whole numbers on your x values, of your x values even, and you'd sort of draw a picture from there based on the information that you have. So what you would have in your exam, what you would come out with is this point here, this point here, this point here, this point here, and this point here. So you would only have the bits in navy there. And what you would have to do then is to join them up in order to get your full marks, in order to show me that you have catered for all the real numbers between -2 and 2. So by catering for those, you would have to sketch your graph like that and fill it in. And what you would be left with is exactly what the marking scheme is showing you there, that curve. I've done a video on graphing functions if you feel you need to brush up on that, and I'll put that in the description as well. So that sort of thing comes up quite a bit, I suppose, especially graph questions, something like that. And it's just important that you're familiar with what they're talking about. That right there, it's like your terms and conditions of the question. It's what they want your graph to look like, I suppose, in terms of like what numbers it has to be in between. Now, another type of question you could get is, let's say one without a graph, and you get an actual number as your answer. And I've just written out, just as an example, the types of answers you could get that equate to a quarter is a quarter written as a fraction, a decimal, or a percentage. And all these things mean the same thing, essentially. But sometimes, well, a lot of the times in your questions, the question will ask you specifically to put your answer in one of these 3 forms. So if you put your answer as a quarter, but if the question asked you to put your answer to 2 decimal places, well, a quarter is correct, but you haven't put it to 2 decimal places, so you wouldn't be getting your 10 out of 10 marks. You'd only be getting 9 out of 10. They usually take 1 mark away for each, for not rounding properly. So we're just going to focus on that in the next minute or two. In terms of all your questions, I've just sort of written out the forms in which your answers could take. So if you look at the blue bits, the question will ask you to write your answer in the form, and then it will say one of these things here. So that, or that. And then it'll say, well, where X is an element of, and then it'll give you a choice for those. So I'm just going to walk through those bit by bit. If it asks you to write your answer in the form, that just means your answer should look like the next thing that they're going to say. So if they say that your answer should look like A over B, that means your answer should look like a fraction. So instead of 0.25, 1 quarter would be your answer, would be the best way of writing that. If they ask you to write your answer in the form ax squared plus bx plus c is equal to 0, well, there's an awful lot going on there, and besides the 0, there's no numbers at all, so sometimes people can lose their minds a small bit on that step. All they're asking you to do there is to write out your answer so that you have values for A, B, and C. So your A, B, and C are going to be numbers, and your X's and your zeros, like, they're not going to change. Your X's, there will be X's in your answer. So if you get something that asks you, the second one there, that one, you might get an answer like 2x squared plus 3x minus 9 is equal to 0. And that's fine. You would have said that your 2 is your A, your 3 is your B, and your minus 9 is equal to your C. I purposely put in a minus 9 there because sometimes people say, well, oh, that's a plus C, but I got a minus 9 at the end. Is that okay? And of course it is. It just means that your C, your plus C, corresponds to your minus 9 in your actual answer. And you might have noticed that that right there, that form is a quadratic because it has an x squared, an x part, and then a constant at the end, or in other words, just a number at the end. The third one here is something that isn't on the Junior Cert course, so I'm just going to put a line through this. Apologies about that. But if you're watching this and if you're in Leaving Cert, a plus bi means that your answer will be a complex number, so it should be written as 3 plus 5i, or 7 minus 6i, or 2 plus 0i. And in a way, you're sort of treating the I like the x up in your second one here. You need an I in your answer in order to get your full marks. But just for now, I'm just going to put a line through that because us Junior Certs do not need that. For the fourth one here, and I'll just get rid of those scribbles. That right there is a fancy way of saying they want your answer in scientific notation. So if your answer was the number, and I'll just go down here, if your answer was the number 3000, well, 3000 is no good because they want your answer in scientific notation. And what that means is they want you to write it as some number, a, by 10 to the power of another number, and your a, the number that you started off with, has to be in between 1 and 10. So, might sound a bit complicated, but I'll show you how we're going to do that. This is normally used for either really, really big numbers or really, really small numbers. So I'll start with like quite a big number, 3000. And if they want their answer as a multiplied by 10 to the power of n, then what you're doing is you're locating the decimal point first and foremost. And like 3000 is the same thing as 3000.00. I usually just put 2 zeros at the end there. I suppose because that would be the way it would be written if I was dealing with money. And so to write 3000.00 in this form here, a by 10 to the power of n, I'm just going to go through a couple of calculations and then I'll give you a shortcut at the end, but it's important that you sort of know where the calculations are coming from. I don't want to just give you a rule for something and you not knowing where it's coming from. Obviously, this number here, from the question it's given, the a, and where did I write that? Right here. Your a has to be in between 1 and 10. And right now, if you look at the number that we have, 3000, well, it's not in between 1 and 10. So what we're going to do is we're going to rewrite this as 300 by 10, because 300 by 10 is the same thing as 3000. Now, again, my 300 here, it's not the same as, or sorry, it's not in between 1 and 10. So I'm going to rewrite this now as 30 by 100. And 30 by 100, remember our 3000 is the same thing as 30 by 100. We haven't changed the value of it, we've just changed the way it looks because that's what the question is asking us. And again, my 30, it's not in between 1 and 10. So I'm going to try that one more time. I'm going to end up with 3 by 1000. And now we have our 3 here, which is in between 1 and 10. So we've gotten that part right. My a is my number 3. And then by 10 to the power of n, well, now we're left with 1000, but we want to write that as 10 to the power of n. So if you think about that, well, 10,000, if we just look, sorry, not 10,000, 1000. It's the same thing as 10 by 10 by 10. And if you think back to your laws of indices, well, that's the same thing as 10 cubed. And a handy way of remembering that is, well, the 3 here is, the 3 there is just the amount of zeros at the end of that number if you're working with powers of 10. So 10,000, or I keep saying 10,000, 1000 is the same thing as 10 to the power of 3. So for our last step, just over here, for our last step, we have our 3 and then multiplied by 10 to the power of 3. So if we were asked that in a question, write 3000 in scientific notation, we'd have to go through this process in order to write 3000 as 3 by 10 to the power of 3. What some people do also is, and there's no harm in this, it's a sort of shortcut without all this working out. They use their decimal point and they go, well, 1 hop, 2 hops, 3 hops. If I move, and I'm going to say move like in inverted commas there, my decimal point 3 spaces to the right, I'll end up with 3.00000, and of course that 3 there is fine. So that 3 is where this one here is coming from, and then the 3 jumps to 1, 2, 3 is where that 3 there is coming from. So that's just very, very briefly what your scientific notation is. That's not really what today's video is about, I suppose. So what I'll do is I have a link to another video that goes through that and gives a lot of examples, and I'll put a link to that below if you feel like you need a small bit more work on that. Okay, so that's our 4th one done there. I'll just take those off. That was our complex numbers. We don't need that until leave insert. That. You might be asked around to 2 decimal places and your answer will look like 2.34 or maybe minus 100.98. The key thing there is you only have 2 numbers after your decimal point. If it asks you to 3 decimal places, then there should be 3 numbers, etc. To 2 significant figures, that means that there should be just 2 numbers that aren't 0 in your answer, except for 1 or 2 special cases. And again, I don't want to get bogged down on that. So if you don't know what significant figures are, I'm going to put a link to another video that I've seen that'll help you out with those, and that'll be in the description below as well. So just for now, your number should look like 25,000, and your 2 significant figures would be the 2 and the 5, or 67 million, and again your significant figures would be 6 and 7, or 0.0078. You'll notice that that's a really small number, but your significant figures are 7 and 8, and again there'll be a link to that in the description. The last one there, if they ask your answers in terms of pi, and usually that's with volume or area, you should leave pi in your answer. So your answer could be 2,500 pi centimeters cubed. Remember your units at the end. But the key thing here is with your 2,500 pi, don't put that into your calculator. They want pi in your answer. So if they asked you to a few decimal places, absolutely you would put 2,500 times pi into your calculator and get your answer out. But in this case, they don't want that. Or you could have 50 pi meters squared as an example. Just a quick note there, centimeters cubed. The 3 there sort of indicates that you're dealing with a 3D shape, so that's going to be volume. And for 50 pi meters squared, the 2 there indicates that you'll be dealing with a 2D shape, which is area. So if you didn't know that, it's sometimes handy to know. All these words, actually, just as I remember, I will put those in the description as well, so you don't need to take notes. Those you can just copy and paste them from there. Now, that's sort of like the first part of the last part of the question, and then they might tell you where x is an element of. So the E there means that x belongs to the next set of families, and you have sort of 5 of those that you need to know. If it's R, if x is an element of R, then x can be a real number. X can be positive, negative, decimals, fractions, it can be 0, it can be any number on the number line. If x is a natural number, it's just your positive whole numbers, and that starts at 1, so it's like you're counting numbers 1, 2, 3, 4, 5 all the way up to infinity. If x is an element of z, z are your integers, and that can be positive or negative whole numbers, so and also 0 as well, so 0, 1, 2, 3, 4, 5, but also -1, -2, -3, and all the way back. Q are your rational numbers, so they can be written as a fraction. We've seen pi up here. Pi cannot be written as a fraction, so pi would be irrational. That's the next one. That's your real numbers without your rational numbers. In other words, your irrational numbers, the ones that cannot be written as fractions. So I'll probably do a video and I'll just go into I suppose the differences between all of these, but you do need to know your definitions of those. If you forget those, or if you just want to make sure of those, all of those are listed on page 23 in your log tables. But the notation with those can sometimes be a small bit confusing. So you do need to have background knowledge before you, of those symbols and those numbers before you go into your exam. Otherwise, if you're just relying on your log tables, you might end up in more trouble than you went into the exam with, I suppose. So I will put a link to log tables in the description as well. There's going to be a lot of links in the description, but just if you want to get yourself familiarized with those. Last thing, make sure you use the right units in your answer. There's 1 mark will be taken off for every units that are incorrect, and also if it's not in the right form. So you're looking at, you could have like all your workings out done perfectly and you could have like your 10 marks in the bag, but let's say you put something as a fraction. Let's say for this let's say up here you didn't put your answer in the form of a fraction, you put it as 0.25, and then you forgot your units at the end. Let's say you put centimeters cubed when it was supposed to be centimeters squared. That means instead of getting your 10 marks, you'd be losing 1 mark for not putting it as a fraction and 1 mark for not putting it in the right, not using the right units. So instead of your 10 marks, you're getting 8 marks. You've lost 20% of your marks. So just be careful about what the question is actually asking you, and make sure you put your answer in the right form. And I suppose just after all that, just getting the question started and getting your marks, there's a couple of bits there, just questions to ask yourself. If you don't know how to get the question started, will a quick sketch help you out? Is there any information on a diagram given that you can add in straight away? Can you break the question down into smaller, more manageable steps? Can you identify the key words in each question? What do they mean? Like, for instance, let's say they talk about a right angled triangle. Well, a sketch of that, a right angled triangle, you should be thinking, oh, it's a right angled triangle. Maybe if I have to find the hypotenuse, maybe Pythagoras' theorem is going to help me out. So that train of thought is going to help you. Do you know how to use your log tables? Do you know where your formula are in those? I know it says it in the pages at the front in your table of contents, but if you know where the pages are straight away, it'll save you those valuable minutes in the actual exam. Did you write out a formula and substitute something into it? Like the last thing, as a teacher, the last thing I want you to do is leave something blank, because if you leave something blank, that means I physically cannot give you any marks. So usually for your exam, if you write down a formula and then substitute something from the question into it, then you're getting, on average, you're getting 4 out of your 10 marks for the question. If you write nothing down, then you're getting 0. So if it says the word slope in a coordinate geometry question, if you go to your log tables, there is a formula for slope there. If you put that down and substitute something into it, even if you're really stuck on the question and you just couldn't make heads or tails out of it, putting down the formula and substituting something into it will guarantee you your attempt marks. So something to be mindful of there. And then just getting your marks, just making sure that you haven't like missed something or whatever. Do your workings explain where you got your answer from? Basically show your workings, because sometimes there's marks taken away from those. Is it obvious how you got from one step to the next? Like, would it be obvious to, let's say, someone in first year or second year who's just doing that now, doing whatever topic your question was on? Is it obvious how you got from one to the next? If you did a big calculation and you just put it all into your calculator, I'd highly recommend against doing that. But if you did do that, can you show that in your workings? Can you give me 2 or 3 lines that show me what you've done? Because otherwise, as an examiner, if I just see the question and then I just see the answer, and even if it's the correct answer, well, I'm thinking, hang on a minute, where did this person get his answer from? Does your answer make sense to the question? So let's say if it's a true or false, if it says true or false and you say 10 pi as your answer, well, that doesn't make sense. You need to say the words true or false or yes or no. So just make sure that you're answering the actual question that they ask you. Is it in the right form? Do you have your correct units? Have you actually answered what the question is asking you, etc. And like what I said before, if a question is asking you whether the statement is true or false, or yes or no, make sure you write either true or false, or yes, or I agree. Make sure you actually physically write that down. Otherwise, you may be looking at only 5 out of your 10 marks, even if you have all your markings. So you need to put in the actual English word and then the maths to back it up. And yeah, I've gone through quite a lot in that video there, but I think that sort of takes into account nearly everything that you need in order to understand what the question is asking you and get your marks for doing all your work and not falling into the pitfalls that some people do, like missing out on their units or not putting their answer in the correct form. So just taking all that into account, I think I suppose key rules: just read the question carefully, make sure you know how to use your log tables, show your workings, and make sure your answer is in the right form and units as well. And just make sure it makes sense. If there's anything I've forgotten in the video, I'll put it in the description below. All the vocab will be there as well. And I think that's it. Guys, best of luck in your exams, and yeah, I hope they go all well for you. Thanks for listening.